Hello and welcome. All right, we are all set. Actually, one more thing. Let me do this. Let's go here again. Okay, this is good. All right. Welcome back. For anyone who has watched the stream before, welcome. To anyone who's new, if you don't know, my name is Tim. I go by Foamy Guy on GitHub and Discord, and I stream at this time each week, 10 a.m. Central Times here, 10 a.m. Central Time here on Tuesdays, on the Adafruit channel, working on stuff related to CircuitPython. If you don't know what CircuitPython is, you can learn more about it at the main website for the project here, circuitpython.org. This is basically a version of Python that runs on tiny computers called microcontrollers. The way it works typically, you'll plug these devices into your computer with a USB cable. It shows up like a thumb drive, and you can edit a Python code file on that drive. When you save it, the microcontroller will run the Python code for you, and then your code can interface with whatever other hardware peripherals you connect to it. So today I have, load up the camera, I have a Feather ESP32S3 reverse, which is also listed on this page. EFT reverse, this one here. So that is the very, very, very quick version of what CircuitPython is. Some devices have built-in peripherals, like this one has a display and some buttons that we can use. Other devices are very general. They just have I/O pins. You connect whatever you want to. This one's kind of a mix because it does also have I/O pins along the sides there. All right, let me move this also. Okay, there we go. Okay. So yeah, circuitpython.org, that's where you can learn more about it. This is what I typically stream about. CircuitPython is open source project that is primarily sponsored by Adafruit. They pay a team of folks, including myself, to work on CircuitPython things. The project itself, learn guides that use it, documentation, libraries, infrastructure, all kinds of other related stuff. So if you would like to help support CircuitPython, one of the easiest ways to do it is by purchasing hardware from them. They also do support a number of other open source initiatives that are beyond CircuitPython. They pay people to work on Arduino drivers and other IoT things. So if you like the work that they do, if you like people getting paid to work on open source software, you can support it by purchasing hardware from them at their website. You can get microcontrollers. You can also get things to hook up to your microcontrollers to make fun and interesting projects with. And that's adafruit.com. And as a reminder, be sure to check back later today, 4 p.m. Eastern, 1 p.m. Pacific, as it says here. There will be JP's product pick of the week streaming right here on all of the same places where you can see me. And there will be a special discount on a particular product that is chosen for the week. So jumping in today, I'm getting back into this Embodiment kit project, which is something that I did do a little work on my own stream. I think not this past weekend, but the one before, I think, on Saturday over on my channel. This, I will give you the very, very brief version. We'll pull up the page for it first, actually. Let's do that. So there's GitHub is open here. So this was a project by this person, Olivia ZZZU. They submitted the code here to GitHub for this project. There's also, looks like I got updated, dropped the supported versions. Interesting. I wonder what this is. We're gonna snippets are not maintained. Basically they're not part and product. Basically, they're saying they won't respond, it sounds like. In any case, though, this project, I think, was for them to write a paper, is what it seems like, right? So they published the code here. There's also this paper that goes along with it. Olivia Zhu, I don't know the correct pronunciation of the last name there. But they created this project and the paper, and they credit Claude as a collaborator on the paper and the project. And if you go through the paper, you could definitely see that that's the case in some places, especially the diagrams and stuff. Like this breadboard doesn't make a lot of sense because all the stuff's laid out sideways or whatever. But the concepts seem genuine, at least. And so this is the project that I am trying to make kind of an Adafruit version of, and the core concept to this project is a microcontroller that is sort of connected to your computer. In this case, they used over the network, so they use ESP32, and they have a bridge server that runs, I think it was in Cloudflare or somewhere for this example. I'm not sure where they put the infrastructure, but they had a bridge server that ran somewhere on the internet. And then what they were doing was they would have an LLM that can send requests to the bridge server. And then this microcontroller would also be sending requests to the bridge server. And it would use long polling so that whenever there was a new request sent from the LLM side, the microcontroller would get it right away and be able to react to it. And the LLM could do things like take readings from a number of different sensors. It could output things, express things into the environment. So it's all about inputs and outputs with the environment. There's like temperature sensor, light sensor, humidity, that sort of thing. There is a screen for it to put a little face on. It can do happy face or sleeping or sad or whatever. There is a beeper, little piezo buzzer for making sounds, a microphone for confirming the sounds. Essentially, one of the central themes of this whole paper and this whole project is this sort of like being able to express into the environment, but also being able to validate that expression happened. Sort of kind of getting at like, what if the LLM asks the microcontroller to beep the piezo buzzer, but the buzzer is like disconnected or dead or something, right? It doesn't work. If the LLM has no way of like getting that feedback and knowing that it didn't actually work, then it will think it buzzed when it didn't, right? Perhaps not the largest problem in the entire world, but that is kind of the central theme of this project, is like give the LLM not only a way to sense the environment that the human's in, but also a way to express things into that environment. And then one step further, because they can sense the environment and express things into it, can tie those together in certain cases. So the buzzer has a speaker, or a microphone, I should say. The buzzer has a microphone so that it can tell when the buzzer's working. There's a vibration motor, a little vibro disc thing there that has a accelerometer, so it knows when that thing vibrates. And then what we're going to add in the Adafruit version also is a light sensor and some neopixels. This project paper talks about doing the light sensor one, but does not actually do it. It's not actually in their code. They kind of document it as like a next step sort of thing. So that is the very quick version, and then more minutely, more specifically, where I am at right now is working on, I think we're going to kind of refactor a bit and transfer over this MQTT version that I have sort of proof of concept going here. We're going to implement one with HTTPServer, and we're going to try to refactor some of the stuff in here so that we can reuse it. Because ultimately, I would love it to be that you can kind of configure whichever channel, I'm calling them, whichever channel you want the microcontroller and the LLM to communicate over. So MQTT, this one is hooked up with Adafruit IO. HTTPServer will run a server on the microcontroller itself. So HTTPServer will be running on here, hosted on the local Wi-Fi network. LLM is running on the computer on the same network, and it can send requests over to the microcontroller. And then I'm actually thinking maybe a third one might be kind of cool as well, is completely local isolated over the USB cable. But that will be a third one we'll get into if the others get done and there's time and stuff. But that's where I'm at. HTTP server is what we're going to do next, and refactor. What is up? Good morning to Liz over in Discord chat. Okay. I do also have this faces thing, so I was working on this part of it. Let me see if I can lighten this up a bit. It's kind of washing out the camera. I wonder if I just set this to a darker gray somewhere right here. Are we gonna get a little bit, go one step lower even. I don't know if auto reload, yeah, it looks like definitely darker in person, but live, right? Trying to see it when I block it off. Send it up worse. Odd, yeah, the camera just does not want to pick up this screen right now for some. Weird. It's not getting, it's getting like way darker the naked eye, but this screen, it's just like camera rather, it's completely bummed by. I don't know if we're gonna get any better, honestly. Oh, and actually, yeah, there you go. A little bit, okay. So yeah, I got these faces the other day and got them all converted from SVGs and stuff, played with the sizing a little bit, and got them layered up in display IO here. And so there's like a bunch of different there's a bunch of different eyes and mouths, and I think they call them blush. A blush. Oh, and eyebrows as well. Different one here. And so it'll be able to, we can delete the nuns actually. I just noticed those were here the other day. Those are just transparent. I don't know why it means those. But the idea is with all these different facial features, we can mix and match them and then have different expressions saved into it. So it can be like, you know, make the sleeping face or make the sad face or whatever, and it can know which combination to use. Having them all broken out like this means we'll be able to animate them as well, potentially. And it makes it super easy to, makes it portable, I should say. It makes it very easy to change to a different microcontroller easily under CircuitPython, right? Because we have the ability to render the images easily. So this is base git test. That's running again. All right, and so we can test it here essentially. So this is running. And so on the microcontroller side, it's basically listening on an Adafruit IO feed for messages to come in, and I can send a message with this script that's loaded up here. If I run it, oh, it needs the environment variables. Yeah. It's actually going to be a pain to hook it up to the run button. I'd have to do the little configuration. I don't know, it's not that big a deal, but it's an extra step. Instead, I'm just going to do it this way. I have this file here, which should load them up for me. And then after that, all of that I forgot to show here, so do it again while this one's showing. See that it does receive a value, and then in this case it sends a value back, and it also, I think, changes the face. Or, well, it can do a bunch of things, I guess, it turns out, yeah. So it can, I don't know, which one is it actually doing, though, if I don't specify. Main. Did not have anything. So command, arguments none. No, it did have the show face. And then, yeah, unfortunately, this face is, it's a different one. It's not the one I was just showing a second ago, but it is also very bright and overwhelms the camera. But we'll switch back to the others once we get back into showing faces. Where is it? The default come from? Oh, I'm looking at the wrong file. This file, I don't know why this is now a mile wide. This file is called command CLI. This one is meant to be more general. With ACK right here, this one is hard-coded. That. So CLI would be more like what the LLM will use to interact with it. This one was just a test, and it is setting it to show the face. Okay. Now we're caught up. And I think I'm gonna start with on the refactor is even maybe go ahead and make this another class, another file, I should say. So let's go here. I'll call it agent. I hesitate to call it agent because I don't want it to be confused with like the LLM agent, but and so what I want this class to do, like basically I want to generalize the parsing of the messages, the getting to sensor data, the responding to the messages. I want to generalize it so that it will be very easy to swap out MQTT for any other channel. Like HTTPServer is what I want to do first, but like I said, USB would be cool. Theoretically, people could re-implement the same thing using any sort of two-way communication network. So the main things we need are receiving commands, parsing them, doing stuff with them, and then returning responses. And I think, I mean, we're already in CircuitPython land. I think we go ahead and just extend group because then it can handle the display stuff, right? Because it's going to be showing the face on the display. So whenever it receives the command show happy face, it's going to want to be able to do that. In order to do it, it should have a group. Yeah, maybe it should have a group instead of be a group, though. So what did I call this over here? I think I have do command and I have handle task. It should really be called, I think, handle message. I think I kind of got myself mixed. Well, maybe it should stay task, and that way it's different from message, which is what the actual name of the MQTT API is. I think I ended up with task because of task queue. Yeah, I think we actually do want to keep task. So the way this class will work is it will have handle task, it will have do command, it will have a way to respond. It's going to hold the task queue. Maybe it should be technically private. Do command. Change these to be specific imports. Oops. And dictionary. So this one will need to change at some point. Right now, the way this is working is these are individual bitmaps for each face, but with the new thing I got, like I was showing you, those are split up. So this will need to be a definition that says like use these eyes, this mouth, this eyebrows, and this blush. But I think it can just be static. I'm going to call it map instead of dict also. Main group is going to be self dot, maybe we should say self dot main group. Okay, sendac is going to exist. No, self rather. And get rid of this. This was from before. When I first started doing faces, I didn't have the mapping yet, so it was just individual, like show happy was one command, show sad was one command, so on. Now there's a show face command and an argument, which has... Right? No, there's actually still different commands, but it is checking for them in the map. It's not using an argument, it's still using the actual command string, but it is dynamic because it's looking them up from the map. Okay. So now send ack. This one will be a little bit different actually. Instead of, how do we want to do this? This part gets a little bit weird. So we want to, I think, embodiment agent. So I think maybe we're going to make a channel object as well. And the channel object, is that right? No, I don't know about that. Maybe not. I don't think we want that. I think we want, instead of send ACK, we want to do that. We need to be able to return, we need to be able to get data back out, back into the MQTT as a response, or for the HTTP example, it would be a response from the request. Okay. I think if nothing else, so probably let's get weird because do command gets called from handle task. Right now, handle task I think just gets called in the main loop. I think we want to return this back up, basically. I think what we want is a def create ACK. So we're going to generate this, we're going to return it. It's going to get returned by do command. It's going to get returned by handle task. That way, the next level up outside of this, CodePy, is going to have the response object and be able to just give it to back to whatever channel it needs to go to. Now, I don't know about the queue being inside, actually, but no, I think that's fine if the queue is inside because the response contains a UUID. It will get actually weird in the HTTP server one. Maybe it should actually be WebSockets. WebSockets is closer to the MQTT version. Trying to think through a little bit like what would happen if multiple, because the whole point of having a task queue as a list is in case multiple commands come in at once, basically. So you could send in like 4 commands to do different things. We would want to go through the list and do them all. Do they really need to go into a queue, though? They might not need to be put into the queue. Maybe we should be thinking of this as just handle a single one at once, get the response, send it back. Where is send ACK? So let's do this part at least. Okay, I think we're gonna want to take a config, which will basically also be defining the sensors that we have connected. So that when we call get sensor readings, we're going to be able to get data from those sensors. Okay. Yeah, so it gets weird to put it in the task queue because then if we have multiples in the queue, like it doesn't really jive with HTTP being able to return multiple responses to one request. We can't really do that. So we'd have to wait. If we wanted to return response for each of them, we'd have to basically wait until we get all the responses and then we could return them all together. And in that case, we would have the code outside of this class would call do command multiple times. So let's say 4 times, pass in 4 different commands. It would get back 4 different responses, acknowledgement objects. It would take all 4 of those, put them into like a JSON list, and then return that. But it does not really need to just arbitrarily call handle task to pop one out of the queue. It is essentially, the HTTP server version is essentially like always reactive. I mean it can send, it doesn't, I guess it's not entirely true. It can be proactive too. It's going to be able to post data. Well, there's nowhere to post data to, actually. Yeah, never mind. There's nowhere to post data to. It is the server. So it's always reactive. It's going to get a request. It's going to return a response. That request could contain multiple commands. That request could contain a single command. But it's always a single request and a single response. It can never be like 1 request and then 3 responses or something. And we need to respond to every request, so we also can't have like 3 requests and only 1 response. Yeah. I don't know if we'll need this in the queue, actually. We might just be calling do command on the command objects. So this is network, this is outside. So this is supposed to be like network agnostic here. This is basically supposed to be able to work with both MQTT and HTTP server. That part we don't care about so much right now. Or we don't care about at all inside of this class. The whole point is to get it out, get this part separated. So the sensor is coming in as a config. Let's do this for now. Let's just say self.sensors, the dictionary. Honestly, why don't we just assume that it comes in? So let's just say self.sensors equals config sensors, and we'll just assume that it's going to be a dictionary. And then what we'll do is get sensor readings. What does that look like in here? So this returns currently temperature and pressure. And I think what this should do is make a data object for sensor in sensors, for sensor should it be a dictionary or a list? I think it should actually just be a list of objects. And then each object is going to have a an actual sensor instance that's been instantiated, and it's going to have the name of the property to call to get data from it. So for sensor in sensors, data, so the way data works currently is a dictionary. So data, the key would be from, I'm going to call this sensor object just in my head so I know that it's not, or sensor config maybe, so that I know it's not the actual sensor instance by itself. So sensor config, and then this will be the data type, or what should we call it? Yeah, I think maybe just type. Data sensor config type equals, and then we get the reading. So that's going to be sensor config sensor. That will be the actual instance, and then we need to get the type back off of it. So we're actually just going to say get adder. What? Go object and then attribute, or yeah. So then the name would be, let's make variables for these. Type equals sensor config type. Sensor equals sensor config sensor. Type sensor type. Type is the property name, which matches what I have here. If we wanted to get into sensors where it's not just a simple property, that would require some amount of changing. That's fine. We don't have any of those just yet, so I'm going to leave this, and we can do that when we get to it. Then return data. Okay, so we should be able to create one of these. Let's make, oops, code. Actually, I guess I already have code embodiment MQTT, so I necessarily need to keep another separate copy. So let's start trying to use that. So we would keep the network stuff. We would drop the task queue. We would drop this. We need to set up our agent instance, embodiment agent class. But let's get rid of a few more things first. Send ACK I'm going to keep for now, but we're going to possibly end up still changing some. Task we don't have. We're doing pool and... Okay, one of them's for NTP, and then one of them's for the other stuff. Okay, fine. We're gonna fix this in a minute. Sensor config equals a dictionary, no, a list we said, of dictionaries. Each one of those has a type, temperature, sensor, MP. Type, pressure, because in this case they actually both come from the same sensor. So here we go, IO loop. We don't have handle task anymore. We will worry about this in a minute. For the HTTPS version, this is not really going to be a thing that happens. What this is doing here is sending periodic sensor readings to Adafruit IO in this case, because it's MQTT using that one. So it's uploading data Adafruit IO. just pushing on a push basis so that it's every 30 seconds. There's a fresh version there, fresh data. Okay. And the HTTP server one does not necessarily have a similar concept of that. There's nowhere to push it to because it's just waiting for requests. Okay, so the main things we need to fix then are get an event, get a embodiment agent. So agent. Oh, we can't. Okay, actually, we're in a bit of a catch-22 here because the sensor is not configured until all the way down here. The MQTT is configured all the way up here. We kind of need the sensor configured first before the embodiment agent, and we kind of want, at the very least, the embodiment agent initialized before the MQTT stuff, I think. Maybe it wouldn't have actually mattered, I'm not sure. Then we pass sensor config here. This is mad because it's not imported. I don't know why I called it. Okay. So whenever a message comes in, let's change this up a little bit. Instead of putting it in the task queue, let's just say response equals, oh, we actually called it an ACK response. Agent dot do command the whole message. Need to look at the old version. So handle task would call, handle task would pop the first one off of the queue, but does it just command it? Does it just send it to, no, it gets the command object part of it. Okay. So we would go message command and then send ACK no longer needs to accept a command, no longer needs to do any data stuff. Actually, well, it needs to say ACK response. It's just going to send what it gets, really. I'm not sure it even needs to exist as a function, honestly. It could just as easily go here, right? Okay, so no more appending to the queue. It is still looping over messages. You could make the case maybe we should loop over all the messages, get all the responses together, and then send it only once. And that may very well be a thing that it does in the future. For now, I'm just going to leave it like this, though, where it's going to respond to each one individually as it's going through that list. That might be everything it needs to work. Let's see. 15. Let's configure sensors. Did I gave it not a list? Let's go ahead and what? A little crazy. Untype is not subscriptable. Didn't return correctly. We got the command here, but it says publishing none. Returning. So for one thing, we're only returning here, but critically that should be fine because it is a face command. Did I not return data? This got deleted, I think. Or I just never returned it, I guess. Okay. This time it sent the response correctly. It did not change the screen, but that's because we are not actually using the display of the embodiment kit just yet, or the main group I called it. So we need to go back into code here, and wherever we had main group before, we don't really need that anymore. Instead, it should be embodiment agent.main group. Display. I just delete that. Okay, there we go. And again, the camera doesn't want to really pick it up very well. But it did change the face this time. Okay. So now this one is basically set up for just MQTT. And it should be quite easy to take sort of the shell of this, rip out the MQTT stuff, put in HTTPServer, and then hook it up so that whenever a request comes in, we check the data inside the request and pass it to do command. We get back the response, and then that would be what we return from the request. All right, I'll take this. We'll just assume that we have Wi-Fi connected because I already have the code for that. We should do the NTP thing still. We should do the sensor setup. We should do this. But then that's where it starts changing. We no longer need IO stuff here. We no longer need socket stuff for MQTT, for IO, for IO, IO loop. Okay. Instead we have this, we create a server. Not actually using static, but I'll keep it for now. Maybe at some point I'll add a page or something. It's really meant to be more of an API though. It's not, maybe we could have a docs page at the least. Kind of nice. I don't actually want to do serve forever either. I think we want need like server dot do one thing. Serve forever is not gonna return, it's blocking. So we want, I'm pretty sure there's one. It's like server dot pick or server dot, there's a single one I think. Poll. It might be poll. Call this method inside your main loop to get the server to check for a new client request. When a request comes in, it'll be handled by the handler. Returns a string representing the result of the poll. I don't really care about the result, so we can just call poll. Server.poll. Do this. Okay. Stopped error. With no other information. Let's get the Python version. We are about out of time, so I probably won't make it too far through this, but I don't trust that the copied correctly now. We should get no library. This in REPL so it's not trying to run instantly. Errors cannot allocate memory. I think it's full. not gonna actually. 1.6 megs free. Memory. Frozen OS. OS error cannot allocate memory. I'm gonna try unplugging it and replugging it, I guess. Do we still fail the same way also? Server stopped error. 474. Server. Full stopped. Need to call start. On a host and a port. Okay. Do the docs say that? It should say right here. Must call start first. So after we create the server, let's say server.start host. We can do this, but I'm not sure actually. Not either. 1000. The thing is though, I don't know the IP. We might want radio dot for ad that it's not about the code we started from, probably, right? Oh, GitHub's doing this thing. This blue bar is like the blue bar of not gonna work on GitHub. I don't know why they bother making this thing move like this. This page is never gonna load. Like, there's no chance. I've sat here and watched, it'll just get to the end and still not load. I don't know why they put the bar there. It's honestly, not even why they. This just gets pool for forever. Wi-Fi, we have to convert it to a string. Alright, I was very close, but it just needs to be a string. Okay, there we go, and it's 111, so we should be able to at least get a response here. And then that's probably where we stop for now. There we go. Okay, so we got the response. Very good. Okay. But I think we're basically ready now. We would make an endpoint that can then use what we refactored here. So this embodiment kit, or embodiment agent class, now can be used inside that server code to do the command, get the acknowledgement response, and then we would send that as a response from the HTTP server. Okay, that is where we're at for now. That is going to do it for the day. As I will always try to remember to do, you can try to, well, you should remember. I'm going to try to remember, but you should definitely remember to check in later today here on the same channel, 4 p.m. Eastern, 1 p.m. Pacific. JP's product pick of the week will be here. There will be a wonderful discount on whatever the special product of the day / week is. As far as I know, Scott's going to be around on Friday for deep dive, and I think that I will be around on Saturday over on my channel. And next week is The next week is normal. The week after, though, we actually have the meeting on a Tuesday. I don't know for sure if I will stream that day or not. We'll have to see. But next week should be normal still. So Tuesday, 10 a.m. Central Time here on the Adafruit channel. I'll be back. Then on the 19th, we'll have to talk about the week after that, though, for the meeting getting bumped to the Tuesday. All right, that is all for now. So long, farewell. Thanks, everyone, for watching along, and I will see you next time.